Okay, yeah, I guess. Okay, the last class. So what I taught in my last class is about OLS, especially about dummy variable, and some other problems in running OLS. Today, I will talk about other problems. This one was kind of the core of modern econometrics and modern data analysis, something called endogeneity. So this kind of endogeneity means we have some kind of correlation. So in case of the, the development and corruption, these kind of issues, there are some kind of, usually the highly developed countries or rich countries or Western European or North American countries, they are called relatively less corrupt. And at the same time, in terms of development, their level of economic development is high. What we think is because of less corruption, they are more developed. Or the other way is because they are highly developed, they control their corruption. That's one thing. Another thing is that in terms of development, maybe some countries like in Africa, their level of development is pretty low. And the level of their development is high. This way. But their corruption is high. Then you can see some kind of correlation. So what we want to analyze is what is the impact of corruption on development. This one. Okay? That's what we want to see. What is the impact of corruption on development? However, we think there are this kind of relationship. We are not seeing this one because corruption is difficult to measure. So, the definition of corruption is different across the cultures. Something totally acceptable in China is thought to be corrupted behavior in United States. And Chinese, they cannot understand at all American behavior at all sometimes. Okay? In corruption, the same thing happens. For the Chinese businessman, it is totally fine. But Americans, they say, no, that is not fair. Similar way, for the American viewpoint, that is totally fine, but from Chinese viewpoint, that is very weird, very strange. So corruption is very difficult to measure, or sometimes, in some sense, very difficult to define. Of course, there are some real corruptions. It is very easily defined, but at the same level, this kind of thing is impacted by culture. Okay? And which culture is better than the other is very difficult to tell. And like most people, they like their own home culture. And they do not understand the other culture. So in that case, the measuring the corruption is very difficult. But what we want to see is how corruption impacts development. But development is easy to measure. This kind of development is easy to measure. Okay? The development is something like GDP. This one is something like $2,000, $3,000, something like that. This is number. Okay? So GDP is easy to measure, corruption is not. Then what happens in terms of analysis? You are not really seeing this one. What you see is this one. And then what we need to analyze is what is the impact of corruption on development, but you only see this number. Okay. This country's GDP is $2,000. This country's GDP is $20,000. This country is rich, this country is poor. Then this country is not corrupt, this country is corrupt. That kind of problem is one example of endogeneity. Okay? And the biggest problem, or many problems that occurs very frequently, is you see this kind of numbers. Rich countries are good, poor countries are bad, and then you are not really analyzing this one. You are only analyzing this one and infer this one. What we need to see is this one, and does it really impact this way? But in case of endogeneity, sometimes you see the other way. It's because there are some kind of circular kind of problem. Corruption impacts development. Then when you make more money, you pay more attention to corruption. Then the degree of corruption decreases, then you are more developed. When you are more developed, people demand less corruption, then you control the corruption. This kind of problem is endogenous. Two variables, they impact each other. So that is the main problem of endogeneity. Economists, we are trying to solve this kind of problem. So in this class, I will say some kind of ideas about this one. So this kind of thing is some kind of concept. Another thing is this kind of demand and supply model. So here is price, and we have quantity here, and we have demand and supply. Then what you can observe is this kind of equilibrium quantity and equilibrium price, this way. Okay? This is basic. The problem is that when both of them are changing, okay? When both of them are changing, then this is demand and supply. Demand changes here, supply changes here. This is another equilibrium. This is another equilibrium. This is another equilibrium. Demand changes here. This is another equilibrium. Supply changes here. What you observe is this kind of thing in data. Okay? When both of demand and supply, they keep changing, what you observe is this kind of data set. Okay? Then, from what you observe is not this kind of demand and supply line. What you observe is this kind of point. When demand changes and when supply changes, what you see is this kind of thing. Then, what is the relationship between price and supply, price and quantity? Nothing. Okay? That's a real problem. In other words, this one is demand curve. Then price equals 8 minus Q this way. Supply curve, price equals quantity this way. Okay? Then when price increases, or when quantity increases, price increases. When this price increases, then this one should decrease. When this one decreases, then price decreases. When price decreases, this one should increase. When this one increases, price increases. There's some kind of circular problem here. Okay? It's mainly because price and quantity, they are determined by solving these two system of equations. Okay? One equation, another equation, there's one solution. When you solve the system of equations, price and quantity, both of them are determined. Okay? When both of them are changing, what you get is this kind of thing. Then what you really see is this kind of data set. Then when you run OLS, you will get nothing. That is the problem. Okay? So in case when you have this kind of endogeneity, development impact corruption, corruption also impact development, and development again impact corruption, corruption also impact development, OLS has some kind of problem. So in that case, we use something called instrumental variable. So in the example of demand and supply, this is supply and this is demand. Okay? Then here is one equilibrium. What I want to identify is this kind of supply curve. Okay? Then how can I do this? Basically, there is something called income. Okay? So in case income, if you make more money, then your demand, you buy more at the same price. Okay? Here is demand and supply. When your income increases, then you can buy more even if the price is the same. Okay? Then demand, this is price, this is quantity. When your income increases, your demand at the same price, you buy more. In economics, we say that this one is demand shift to the right. Okay? So at the same price, you buy more. So when you make more money, more income, then you buy more at the same price, demand shifts to the right. Then what's the new equilibrium? This one. Okay? When you make more money, then you buy more, demand shifts to the right, equilibrium price and equilibrium quantity increases. Okay? This is what things means. In other words, there are some very luxury cars, let's say BMW. This one's very expensive. But even in Chinese, even if the BMW price increases, Chinese people tend to buy more. Okay? That does not make any sense. In basic economics, when price increases, quantity should decrease. When price of BMW increases, then Chinese people, they should buy less BMW. However, what you observe is even if the price of BMW increases, Chinese buy more BMW. Why? Think about income. The income of China has increased. Okay? Then when you make more money, When you make more money, your demand for the BMW increases. Okay? Then demand shifts to the want. Okay? Then what happens? Equilibrium price increases, equilibrium quantity also increases. Price increased and quantity also increased. Okay? Then this one is very strange. Price increased, then quantity should decrease. Why? This one is because of the income. When your income increases, demand shifts to the right, then this one, basically there is some change in equilibrium. Increased price, increased quantity. Okay, that's one thing. The other thing is that when you make less money, okay, when you make less money, then what happens? This kind of, at the same price, you buy less. Demand shifts to the left. Okay? Then this is new equilibrium. New demand, this is new equilibrium. This way. Okay? Then what happens? When you observe only this one, supply is there, only demand changes because of income. Okay? Then what you observe is this one, and this one. Then what is this one? This is supply cost. Okay? When both of them are changing, what you observe is something like this. Then you cannot find what is demand or what is supply. Okay? But when only income is changing, demand and supply is there. When you change your income, then demand is shifting. Okay? And when only demand changes, not the supply, you find these 3 points. And with these 3 points, you can find not demand, but the supply. Okay? So this is the logic about how to solve this kind of endogeneity. In case of endogeneity, you cannot use OLS. When you run OLS, you are analyzing this kind of thing, then you will get relationship between price and quantity like this. Oh, there's no relationship between price and quantity, something like that. Then this is a problem. Even if you find some kind of relationship, that kind of thing is not reliable. You cannot trust the result. So when your variables have this kind of endogeneity problem, then you need some variable like income. This income, here is demand and supply. This one is from the outside of the system. This is a system of equations, but this one only changes demand, not the supply. Okay? So when only demand moves, then you can identify supply cost. So this is concept of instrumental variable. Some variable like income, we call it as instrumental variable. This variable allows to identify supply curve by changing demand. Okay? So in this kind of thing, we can write this kind of demand and supply. Supply equals price equals quantity, and demand equals price equals 8 minus Q, and plus some kind of thing. This one is function of income. Okay? Income also impacts this kind of demand function. Okay? When your income is high, your demand function will be this one. When your income is low, your demand function will be this one. Okay? So income also shifts this kind of thing. Okay? Then when you have income here, you can identify this supply relationship. Okay? And this income is called as instrumental variable. And this one should be exogenous variable. Exogenous. A lot of people, when they do not learn econometrics, they call it exogenous. No. Okay? When somebody says this one, somebody pronunciates this variable as exogenous, I say, oh, he knows nothing about data analysis. This one should be exogenous. Okay? So when you pronunciate this one as exogenous, then some people will think, oh, he knows something about econometrics. He does not call it as exogenous, exogenous. Okay? So in this kind of system, instrumental variable is required. This kind of thing is exogenous variable. Okay? Then when you have another exogenous variable here, okay? So in case of income, then it will identify this kind of supply curve. Okay? Then what you want to identify demand curve, what do you need? In this case, you have another instrumental variable or supply. For example, supply is also function of technology. Okay? So in this case, here is price and here is quantity. You have demand and supply. This is supply and demand. Okay? Then, when technology improves, when you have better technology, okay, then supply shifts to the right. At the same price, because of better technology, you can supply more. So supply shifts to the right, this way. Okay? But when you cannot use that kind of good technology, then supply shifts to the left. Then what you identify is these 3 points. Then with these 3 points, you can identify demand curve. Okay? Supply curve changes, and because supply curve is changing, you can identify demand curve. Okay? This kind of thing, when you have better technology, for example, in case of cell phone, nowadays, because of better technology, the quality of this one is much better than 10 years ago, but this one is even cheaper than previous price. Okay? So that kind of thing. Because of better technology, price decrease, you are selling more. Even if it is the better technology. That kind of thing. Basic idea, higher technology, then price should be more expensive. But in case of demand and supply logic, that kind of thing is also possible. Okay? So in this kind of thing, technology is exogenous variable. This one is instrumental variable. Okay? Then income allows to identify supply. Technology allows to identify demand. Okay? So in this kind of thing, when you have two equations, here, what you have here is price and quantity, price and quantity. Okay? Indeed, I can write it down also in this way. Quantity equals minus price and something. Okay? Then here, when you see this kind of variable, this is equation number 1, equation number 2. Okay? The same as one over there, but this one and this one, in the second equation, this one and this one, they are related. Okay? When price changes, quantity changes, quantity changes, price changes. Price changes, quantity changes, quantity changes, price changes. Okay? So this kind of P and Q, these variables are called as endogenous variable. Okay? When they are kind of circular relationship. Okay? Then we call these variables as endogenous variable. We call these variables as exogenous variable. So here we define one as endogenous variable, the other one is exogenous variable. When you have two endogenous variables to identify the entire system, you have one exogenous variable here, another exogenous variable here. If you are only interested in this one, then you need only one exogenous variable here. Okay? So this kind of the number of endogenous variable and the number of exogenous variables in general very important. Okay? That's why this kind of endogeneity problem is so complicated. But anyway, at this moment, sometime or you may not see this kind of thing at all, but I want to explain what is endogeneity. To teach this kind of instrumental variable completely, it requires at least one semester. But the concept, or when you see something endogenous and exogenous, you can think about this kind of thing. Okay? So, demand and supply, this is the simplest example. Then, when demand changes, we can identify supply. What changes demand? That is income. Income is called as exogenous variable. When we have exogenous variable in demand curve, we can identify supply curve. Okay? So that is the logic. And if you understand OLS clearly, then it is almost impossible, but anyway, this kind of endogeneity is something upgraded version of OLS. Okay? Yeah. And I can see another thing that is about panel data. So I'm not sure when I will teach this kind of advanced topics, but let's talk about some panel data. I briefly mentioned something about panel data in my last class. The purpose of this time is when you hear something called random effect, and something called fixed effect, and something called pooled OLS, you may think, oh, I heard about it. That's the purpose of this one. Like, panel is relatively simpler than the endogenous problem, but this one is more frequently used. Because of the nature of the data set, then in the panel regression, what I emphasize is this one, fixed effect. Okay? This one is most important one. And something called pooled OLS and fixed effect and random effect, or what I mentioned in my last class, fixed effect is related to a dummy variable. Then to explain this one, I need to explain the fixed effect, I need to explain pooled OLS, and then random effect, and then finally fixed effect. Okay? One is, so in case of panel data, what is more complicated is you have this kind of thing. YIT equals alpha IT plus XIT plus beta IT plus UIT this way. This is the problem. Okay? What you have in OLS, what you have is something like yi equals alpha plus beta xi plus epsilon I, something like this. Okay? You only have I. Okay? So basically this one is some kind of individual. Person number 1, person number 2, person number 3, person number 10. When you have 100 people, you are seeing the relationship between x and y. That coefficient is beta. Okay? This one, the difference is you have t here. This t means time. Okay? So this kind of time means that person number 1 at the year of 2000. Person number 2 at the year of 2000. Person number 3 at the year of 2000. Then you also have person number 1 at the year of 2001, person number 2 at the year of 2002, person number 3 at the year of 2003. Okay? So what you have is this kind of individual equals 1, 2, 3, and time equals at 2000, 2001, this way. Okay? So this kind of thing, when you have this kind of data here, this kind of data is called as cross-section. Okay? At the year of 2000, you have person number 1, person number 2, person number 3. Okay? And there's another cross-section and another cross-section every year. Okay? Then this kind of thing is cross-section number 1, cross-section number 2, cross-section number 3 across the time. That kind of data is called as panel data. Okay? So for this one, there is no problem in running OS. Okay? Forget about this one. Okay? At the year of 2000, you have this kind of thing. Okay? Then, OLS is not a problem. At the year of 2001, another OLS is not a problem. At the year of 2002, the other OLS is not a problem. Okay? So that one is in terms of OLS. The other thing is when you have panel data like this, basically this one assumes every person at each time they have different alpha and different beta. Okay? Every person at the person number 1 at the year of 2000, they have their own coefficient. However, this kind of thing, you cannot estimate this kind of thing. What's the number of observations? I times t. You need to identify this one and this one. There are too many variables to estimate. In other words, when you estimate this one, you lose entire degrees of freedom. Okay? You have I times t kind of thing. You have more things to estimate. Okay? So you need to change this kind of thing. Okay? There are too many things to estimate. So this is ideal, and when you use local statistics, identify this one is also possible. But let's talk about it later. Then, in case of pooled OLS, what you estimate is YIT equals alpha plus beta XIT plus UIT, this way. Previously, what you had here is alpha IT and beta IT here. Okay? I means individual, T means time. Okay? Each individual at each time, they have different coefficient. However, in that case, we cannot estimate it because of degrees of freedom problem. Then in case of pooled OLS, this one simply estimate alpha and beta. Okay? This one is the same as, almost the same as OLS. In case of OLS, you have alpha and beta you estimated. Okay? So at the year of 2000, you can run OLS, not a problem. Okay? At the year of 2001, you can run another OLS. at the year of 2002, you can run another OLS. Okay? That is cross-section. In case of pooled regression, that means forget about the time. Okay? This one is one OLS. This one is another OLS. This one is third OLS. Pool them together, it only increases the number of observations. Okay? So you have data in 2000, you have another data in 2001, you have another data in 2002, forget about time. Okay? This one is the same as individual 1 has 3 data points, individual 2 has 3 data points, individual 3 has 3 data points. The number of observations increases by 3 times. Okay? That's the meaning of pooled OLS. You pool it. Okay? And then only increase the number of observations by t times. Okay? When you have 3 years, number of observations increases by 3 times. So this kind of pooled OLS is one Bayesian method. So this one is one Bayesian method. Okay? So pooled OLS is also some kind of basic analysis for analyzing this kind of panel data. Okay? Forget about time, pool them all, just simply increase the number of observations, and let's see what is the relationship between alpha and beta. This one simply thinks panel data as more number of observations. The problem is this kind of error term. Okay? The error term, the thing is that this person number 1, he has, this is the same person. Then at the year of 2000, year of 2001, at the year of 2002, because this is the same person, there are something similar or something the same for this one. This guy is good at, let's say, English, then his English skill is pretty good in 2000, English is pretty good in 2001, and English is pretty good in 2002. This guy has poor English, then that kind of impact is, what is it? Persistence across the time. Okay? Then when his English is good, then the error term is probably high. Another high error term, another high error term. When his English is poor, low error term, low error term, low error term. Okay? So there are some kind of correlation for this error term for some people. Okay? The same person, he has some kind of characteristic. That kind of characteristic is persistence across the time. Okay? Another thing is this kind of time fixed effect. At the year 2020, everybody suffered from Corona-19 virus. Okay? Then, compared to the before year, there are some kind of time fixed effect. Okay? This kind of the virus, it impacted entire person in the society only in this year, probably next year, but not the year after next year. Okay? Then at the year of 2020, every people, they got some kind of negative effect. Okay? Then the error term is likely to be big. Okay? Then that kind of big error term is shared or persistent across the year. Okay? So you can think about some individual fixed effect, also some kind of time fixed effect. Okay? So So panel data, in case of pooled OLS, we forget about it. In case of pooled OLS, you have dataset number 1, dataset number 2, dataset number 3. All the dataset is considered with the same weight. Okay? You only increase the number of observations by number of time. But when you think about this kind of thing, there must be some kind of correlation, especially in terms of error term, for the same individual for the same time. You have individual fixed effect, you have time fixed effect. Okay? So one thing that we can talk about is something called individual specific effect. In this case, you can think about like this: YIT equals alpha I plus XIT data times XIT plus epsilon IT or error term. It doesn't matter. I write down UIT, so let's write use this kind of thing, epsilon IT. Okay? This kind of thing, in case of individual specific effect, is trying to control this individual number 1, individual number 2, they are different. Okay? This guy speaks good English, this guy speaks poor English. Then there are some kind of difference, systematic persistence difference between these two people. Okay? That one is captured by this part. Okay? In case of pooled OLS, this kind of alpha is the same for everybody. Okay? This one in some sense assumes the level of English is same for every people. Okay? Then it calculates average English skill. Okay? But each individual, they have different kind of English skill. Then this kind of alpha I is different. For the individual number 1, good English skill, then this one is high, this value. Alpha 2 is relatively lower. Alpha 3 in the middle. Okay? So this one adjusts individual specific effect. Okay? Then by using this one, you may control or you may use more information. In other words, the variance may be smaller. Okay? When you estimate in a better way, your variance is always relatively small. So this kind of thing is called as individual specific effect. Okay? Then, when this one works, your life is simple and beautiful, but that's not the case. I'm sorry. That's why panel data is complicated. When this one is simply becomes fixed effect, life is beautiful, but I'm sorry, that's not the case. But conceptually, it's the same. Okay? Then, the problem is that this one and this one. This one and this one, it can be correlated. Okay? This is his English skill. Think about this is his income. Okay? Then, when you have better English skill, then your income tends to be high. Okay? when your English skill is high at the year of 2000, your income is probably very likely to high at the year of 2000. Okay? Your English skill is still high at the year of 2001, then your income is still high at the year of 2001. Your English skill is high at the year of 2002, your income is still high at the year of 2002. Okay? This is the same person. Okay? He has some kind of thing, and this one also impact this one. Okay? Same person, his income, or same person, his health, same person, his education, they are correlated. Okay? Concept is the same. In case of fixed effect, what people want to identify is this kind of individual specific effect. Okay? Then when you run OLS with this individual specific effect, this one and this one is correlated, then OLS is not consistent. Okay? So that is purely mathematical result. Then question is how to solve this one. Okay? This one and this one is correlated. Then how to solve this one. Okay? So I can teach this one in mathematical way, but it will make your understanding more confusing. So let's skip that part. Okay? Just intuition is enough. Same person, then this one and this one, they are correlated. So this model does not work. Okay? Then what we do is something called random effect. Okay? So in case of random effect, what we want to analyze is this one, but this one does not work because this one and this one is correlated. Okay? That kind of correlation is problem. This one is something similar to multi-collinearity. This one and this one correlated. Oh, that's a problem. Then what is the solution? Random effect assumes alpha I is random. Okay? So now this one is random. We cannot run OLS because this one and this one is correlated. But when this one is random, okay, random variable cannot be correlated to another variable. Okay? So this kind of assumptions instead, this kind of individual difference, in my case, my example is something called English skill, where as an entire person, I have some characteristic. Okay? That characteristic, random impact assumes is random. Okay? My characteristic may be high, may be low, maybe on average, it is randomly determined. Okay? That is the random effect. In my case, I just picked up some one skill, something like English. But if we think myself as an individual, and there are some kind of my characteristic, then that characteristic in some sense can be random across people. Okay? People number one, he has randomly high alpha I. This guy has randomly low alpha Y. This guy has randomly average alpha I. what matters in statistics, when this one, there are many individuals, okay? Then, when the sample size is big enough, this kind of randomness assumption holds, okay? So when you select people really enough from randomly, then this kind of randomness assumption, you can think this one is true. So random effect thinks that this alpha I is random. Okay? Then this one and this one is also random. This one and this one is also random. They are not correlated. Okay? Then problem solved. That's it. So what we want is this kind of individual specific effect, and assume that this one is random. Then you can solve this kind of thing. Then what is the next thing you need? You need to check alpha I is really random or not. Okay? So you need to check those kind of things. And then the something indifferent is something called between estimator. I'm trying to explain this kind of things without any mathematical notations, and I found some problem. Okay? So this is one way, but maybe this is not enough. Then you may need something called between estimator. That is, okay, this is the same person. Okay? Then let's make the average of this one. Okay? Let's make some average of this one. Let's make some average of this one. What's the best part of this kind of between estimator? When you make average, the number of observations decreases. Okay? But when you make this kind of average, what is the better part? Error terms, they also cancel each other. Okay? This one has some kind of positive error term, this one has some kind of negative error term. Then positive and negative error term, they are cancelled out. So in terms of the variation of error term, when you average this kind of thing, then the number of observations decreases. At the same time, the error term variation also decreases. And then person number 1, person number 2, person number 3, they are all different, and you can run some kind of OLS. Okay? That one is different from pooled OLS. Okay? In case of pooled OLS, you use entire observations. Okay? For each individual. In case of between estimator, then you make the average of this one. And then run only one regression. Okay? Then you are comparing the difference between individual number 1, individual number 2, individual number 3. Okay? That is why this one is called between estimator. Okay? Then the next thing is something called within estimator. what is within estimator is, now this time, think about only person number 1. Okay? In this case, he has 3 data points. But when you have something like t equals 2020, 20 data points, individual number 1 has 20 observations. Okay? Individual number 2 has another 20 observations. Then, in case of within estimator, you are running regression only for individual number 1 with 20 observations. Okay? That's possible. And you are running the regression only with individual number 2. And you are running regression only with individual number 3. Okay? Then you will get alpha 1, alpha 2, alpha 3. Okay? Then take the average of this one. Okay? That is different way of calculating alpha in this way. So within estimator, you are running regression only person number 1's data. Then within the person number 1's characteristic, you will find some information. Okay? Individual number 2, it has enough information, then you are running the OLS only with individual number 2. Then within the variation of individual number 2, you will get some value of alpha 2. You can do the same thing, then you will get alpha 1, alpha 2, alpha 3. Then make the average of alpha 1, alpha 2, alpha 3. Make it as alpha. That one is called as within estimator. Okay? So between estimator, you make average of the data set. And then try to find what is different across individual number 1 and individual number 2, individual number 3. That's the way. Within estimator, run a regression for individual number 1, run another regression individual number 2, and then run another regression individual number 3. Okay? Then make the average of those kinds of things. That is within estimator. Okay? Then when you mix between estimator and within estimator at the optimal rate, okay, that one becomes fixed effect. Okay? Then you can calculate this alpha I without the correlation. That's the concept of panel data. Okay? So in this kind of concept, basically you have this kind of thing. But you cannot do this. So you change into pooled OLS, just sum them up. Okay? Just increase the number of observations, calculate it. The simplest way. But each individual has some kind of characteristic. What we want is something called individual specific effect. So each individual has some kind of own characteristic. However, this one and this one is correlated. In case of random effect, let's make alpha I random. In case of fixed effect, think about between estimator and within estimator and mix them, then you will get this kind of individual specific effect. Okay? That's the concept of panel data. So in most cases, you will use this one. Okay. So in Stata, the command for panel data is xtreg. Then the basic setter is random effect. When you want fixed effect, at the end of the command, use fe, fixed effect. This way. But anyway, you will see some panel data, then you may not remember or understand entire of this kind of thing, but just think about the concept that I taught today. Okay? Then let me stop today.